I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
The world is entering a new digital era, driven by artificial intelligence. But behind the excitement lies an invisible crisis. As AI systems become more powerful, they demand extraordinary amounts of computing power, data storage, and energy. The very engines driving innovation, massive data centers, are now reaching their physical and environmental limits. By 2026, data centers could consume over 1,000 terawatt-hours of electricity every year, roughly equivalent to Japan's entire energy use. Nearly 40% of that power goes just to cooling. The numbers are staggering, and they reveal an uncomfortable truth. Our planet may not be able to sustain the digital future we're building. So where do we go from here? Surprisingly, the answer may be up. Imagine this. Instead of housing data centers on land, we place them in orbit, above Earth, powered by the sun and cooled by the cold vacuum of space. What once sounded like science fiction is rapidly becoming a practical engineering solution: orbital data centers. By moving data processing and storage to orbit, companies can dramatically reduce the physical and energy constraints that plague terrestrial data centers, while also improving global data accessibility and security. These orbital platforms wouldn't replace traditional edge computing. Instead, they extend it beyond Earth, forming what some experts call the space edge. Instead of sending massive amounts of raw data from satellites down to Earth for processing, orbital data centers can analyze that data in space, transmitting only the most valuable results back to the ground. This approach saves bandwidth, cuts latency, and enables near real-time decision-making for everything from Earth observation and defense systems to interplanetary missions and global IoT networks. In essence, orbital data centers bring computing power closer to the data's true point of origin, whether it's a climate monitoring satellite, a lunar probe, or a network of autonomous sensors spread across continents. So what makes space such an attractive home for our future digital infrastructure? First, energy. In orbit, solar panels receive about 40% more sunlight than on Earth, free from atmospheric interference or night cycles. That means orbital centers can run on continuous, renewable power, no fossil fuels, no grid dependency. Second, cooling. The space environment naturally sits near minus 270 degrees C, offering a perfect energy-free cooling system. Traditional data centers waste nearly half their power battling heat. Space can solve that effortlessly. Third, global connectivity. Positioned strategically, orbital facilities could provide simultaneous access to multiple regions, reducing the need for countless terrestrial centers and boosting speed for distributed users around the world. Several technological breakthroughs are turning this vision into reality. Reusable rockets from companies like SpaceX have cut launch costs by over 60% since 2015, making large-scale orbital infrastructure feasible. Advances in radiation-hardened computing now allow processors to survive space radiation, something unthinkable a decade ago. Meanwhile, autonomous maintenance robots and AI diagnostics can detect and repair faults remotely, solving one of space's biggest logistical challenges. And energy-efficient chips, optimized for low-power, high-performance operation in orbit, are redefining what's possible. Companies like Uboteka have created AI processors that deliver teraflop-level performance while using just 5 watts of power, perfect for solar-based systems in space. Environmentally, the advantages are enormous. A single orbital data center could eliminate 500,000 tons of CO2 emissions each year compared to an Earth-based facility. It would save millions of gallons of cooling water per day, operate entirely on solar power, and require no land or construction permits. Economically, the long-term picture is just as promising. Although initial launch costs are high, orbital centers have no property taxes, no land costs, and drastically lower operating expenses. The result? lower lifetime costs over a decade compared to today's mega data farms. And this isn't just theory. The revolution has already begun. Startups like OrbitsEdge, LEOcloud, and even giants like Amazon Web Services are experimenting with space-based processing platforms. AWS has already tested machine learning workloads on satellites, analyzing data in orbit before it ever reaches Earth. LEOcloud, in partnership with Axiom Space, plans to deploy the first modular data centers aboard the International Space Station by 2025. Meanwhile, Airbus's Space Data Center project in Europe is preparing a 2026 demonstration mission focusing on real-time analysis of Earth observation data directly in orbit. The European Commission and Thales Alenia Space have also completed a landmark feasibility study showing that space-based data centers are technically sound, financially sensible, and far greener than ground-based alternatives. As project manager Damien Dumestier put it, "We found a solution that makes financial sense and has a smaller carbon footprint than any Earth-based model." Europe sees this as more than a sustainability initiative. It's about digital sovereignty. By hosting computing infrastructure in orbit, nations can secure control over their data, reduce dependency on foreign hyperscalers, and establish leadership in next-generation space technology. These projects could also spark breakthroughs in in-orbit servicing, sustainable propulsion, and radiation-hardened electronics, driving innovation across multiple industries. Of course, challenges remain. Future orbital data centers will require eco-friendly launch systems producing far fewer emissions than current rockets, sustainable station-keeping propulsion to maintain orbit without fuel waste, and rigorous space debris management to keep orbital zones safe. Latency is another hurdle. For applications demanding sub-10 millisecond response times, orbit may still be too far. Yet with emerging optical communication networks and quantum-secure links, this gap is shrinking fast. Legal frameworks and data sovereignty laws will also need to evolve, addressing ownership, privacy, and jurisdiction for off-planet infrastructure. But the direction is clear. Analysts predict the first commercial orbital data centers will be operational by 2027 or 2028, initially serving AI model training, Earth observation, and scientific computing. And as launch costs drop further, we could see a fundamental reshaping of global computing, where a significant portion of humanity's digital infrastructure operates beyond Earth's atmosphere. In the coming decade, the cloud may no longer be a metaphor. It might actually live among the clouds, in space. By uniting the power of AI, quantum technology, and orbital engineering, we're not just solving Earth's data crisis. We're building the digital backbone for an interplanetary civilization. This is the next great leap for both computing and humanity. Thanks for watching. Subscribe, follow, or visit IDSTH.com for more cutting-edge defense and tech insights. See you in the next one.